Yes, thank you very much for the introduction. I'm Ruben Bridgewater, and well, errors. Yeah, here we have one. We probably almost everyone has run into one of these before, and I personally would say there are good and bad errors. And my talk today is going to be about error handling in general and how to do it right, because error handling in JavaScript is not so easy. So first of all, a little bit more about my person again. I'm a Node.js expert. I'm one of the most active collaborators on Node.js, and I do consultancy. I do consultancy as a software architect, and also do trainings on Node.js in general. And while doing that, I've seen a lot of code that actually is not really good when it comes to error handling. People often make their life pretty hard dealing with errors. And the reason for that is in JavaScript, errors work a little bit different than in most other languages. So most languages, for example, would never allow to throw primitive errors. But that's perfectly fine in JavaScript. But when you do that, you will lose all information because you don't have a stack trace. You only have whatever you throw, and maybe it's an object, maybe it's a string, or whatsoever, but there's no further information about what actually has happened in that moment. And that's not the only problem. So JavaScript, as an asynchronous language, has the difficulty that stack traces are not always useful. And then people just tend to ignore them or don't really see what is really important. That is not the case always anymore, and I'm going to show you why. So let's start with the more traditional stuff, right? Callbacks. This is a valid example if you are still using Node.js 8, and I've seen code like that before. Like mainly in tests or something like that. This is obviously super bad, because here it's not only a race condition that the folder might not be there when you actually write the file, but you also don't know if any of these operations succeeded or not, because no callback was provided in which you would either handle the error or deal with the control flow of the application. So this is just synchronously calling two FS operations right after each other. And it's like a fire and forget operation. You have no clue what happens. Please never do that. I changed the validation code in Node.js when it came to Node.js 10, and this will throw an error there, that there is no callback. So here we do it a little bit better, because now the race condition is gone, at least, and we would only call write file after the folder might have been created. I say might have been, because if there is an error again, well, we would call the second operation as well, and it would just fail as well, but we would not know that either of these has happened. And you should always know what's going on, otherwise you really have a hard time debugging your application later on. And here is another bad example. So callbacks have the error first arguments. So the very first argument in any callback in the Node.js landscape is as a paradigm that you always provide the error. And here the user, instead of testing for the error, if it exists or not, they checked if data existed. Well, mkdir actually does not return any value. So even if everything passed, it would actually expect it did not pass in this case. And that's pretty bad. You should always check for if error instead of if something returned, if something positive returned. That's the only real indication that it worked. Now, promises were our savior in a way, right? They came around and we don't have to deal with the callbacks of hell, very deep structured code that is really difficult to read anymore. Well, turns out promises as a traditional thing do not save us in all cases. Because here, it actually looks like everything is working fine because we have a catch handler, we have the promise chain, right? And then we call the second call, and we catch the errors. Well, actually, we don't, because we actually create a new promise chain inside of the first promise handler. And if there's an error while writing the file, we would not be notified about it, besides having a so-called unhandled rejection in Node.js. But that's only specific about Node.js. And if we would not have this automatic process that we track those things, then there would not be any notification about it, and you would have no clue what happened. So this is also not good. And it is still possible to write similar code as the callback of hell with this old callback-based things, promise-based things. It turns out all these things pretty much eat away our errors. And if we don't have an error, we cannot debug our application properly, because our code might just continue to run somewhere else, and we don't know that the actual error happened somewhere significantly before, and this results in a long debugging time later on. So please, errors are actually cool. They're good. They help us and provide us with information in case something bad happened. And it always happens, because we are human and we make mistakes. That's fine. We just have to deal with them properly and make our life easier how we get the information. So promisifying code is also a thing. You know, like the promise constructor is something actually not so easy to deal with. And there are still a couple of APIs out there that only support callbacks. So people all pretty much switch to using promises. And if you want to use those promises on the callback-based API, you have to make sure that your calls are actually promisified, how it's called. But in this example, there are multiple problems. First of all, this function call might either throw an error synchronously, or it might reject, or it might return a promise that resolves. So you don't really know if this call works synchronously or asynchronously, which is already super bad, but that's just the least of the problems in here. The promise constructor will catch all synchronous errors happening inside of the promise constructor, which not every developer is actually aware of. But that is actually a good thing. And so the second assert call in there, input is true. And when that fails, that's fine, because then it returns a rejected promise. Cool. Awesome. Now we go to the actual API that we want to promisify, and we provide a callback there. We check for the error, and then we do some other stuff and resolve. It all looks fine, right? Well, turns out it is not. The reason for that is a promise can only have a single state. It can only be resolved or rejected. It can never be twice at the same time. So as soon as a promise is either resolved or rejected, it will stick to that, no matter if there is more code continuing to run inside of the promise constructor. And that means we have a dead zone. We have no clue what is actually going on in that code part of our application. So let's just think about it. If there's an error, then our reject call would be called. That's cool. So the promise is now rejected. It has that state. It won't change anymore. But the code flow will continue to run because the code was not returned at that point. And now the sync API with side effects will still be called, no matter that the promise is already rejected. And now it will provide res, and that's very likely undefined in this case. And we don't know what happens there, but here is just an example for it. So the sync API with side effects randomly throws 50% of the time, and otherwise it's accessing data lengths, and it does that unconditionally. The callback API just is a asynchronous API where I have a set timeout, and 50% of the time it actually returns an error, and otherwise it returns data. Now let's combine this information again with the part before. And now we see that the sync API with side effects, if the error actually returned from the callback-based API, now it will throw an error in all cases in the sync API with side effects, and that is not caught by the promise constructor. What it is going to result in is an uncaught exception, and it's super bad. Even though you thought, well, the promise constructor normally handles everything, right? It does not in this case. And you could also call resolve afterwards. Let's say the sync API with side effects passed because we had a positive result with data, so the error case was not taken. No, the sync API with side effects won't pass. Now we have an even worse problem because this promise will never, ever resolve at all. Neither reject this called nor resolve. So doing all these things, I don't know, but it's just a really tiny bit of code, and there are a lot of problems that you have to think about to actually do it right. So what you can memorize already is promissifying APIs on your own is not as easy as it seems, and I would even go so far and say, if you're using promises, you're using them wrong. Let's get to some more real-life examples. Yeah, what I actually encountered as a consultant in companies, and one of the things that I've often seen, as I said before, is that people actually return primitive errors. Sometimes they do without even noticing. So in this case, they also promisified an API, and they say, okay, the template was not found, and they concat that with the actual error returned from the original API. Now, the original API hopefully had a valuable stack trace, but as soon as you concat that with any string, that will be gone. There is no stack trace on this error anymore because it is a string now, and when you call toString on an error, it is just the constructor class in combination with the message, and there's no stack trace. So you lost valuable information. Please never do that. Normally, the error that was thrown already contains the necessary information. Do not manipulate that. Do not change it. Maybe create a new error and then add the received error to that one as a property or something like that, if you have, like, I don't know, whatever. Yeah. And you can throw other things, as I said. You can even throw arrays. I've seen that in modules in the Node.js user landscape. And people did not want to switch. They were fond of that pattern. And this is really crazy for me because it makes your life so difficult. You just have no idea what's happening. Let's have a look at the example, what's actually the output in this case. And it is, in the first case, you only see the array that was thrown. So it looks like it just logged a normal array, and that's it. It just is exactly that. In the other case, you have a nice stack trace below, and you would see, like, the first line is actually the user line code. The other is Node core stuff. Also, this is also from a customer from my and I stripped down the code. This is an express route handler. And here they deal with the errors in a pretty bad way, especially also for the user that receives that error in the end. So they have a database call, and then if the database call succeeds, they check if it seems to be an array, and if it is an array, then they just return it to the user if it has at least one entry. If it does not, they say it was not found. All right, well, actually, I would say that's not right, because the front end should handle that case. You should not say it is not found, because the actual call passed properly. And even if there is no data in it, then that might be a valid entry. In the error case, so maybe there was a network error, all right, but also it could be a validation error inside of the get data call. You know, the query itself might not have been valid. if that's the case, then they would always log a 500 to the user without any further information. So they don't know if it is actually just a bad input that the user provided, because you maybe even had an error in your front-end side code, and it turns out you now send the wrong query to the backend. And they also do not log the actual error. They don't know what happened. They just ignored it. They just don't even put the error in the catch clause. So in this case, it's like they don't know what happened. And it's like, I don't know, it's like flying a plane with a mask on your eyes. I don't want to do it. Because then ends up in a pretty bad debugging horror. And I debugged application for hours, and where I wanted to shout and scream, And I would want to invest that time differently, and also invest that time better for the company I'm working for. So investing the time in proper error handling in the beginning normally results in a significantly faster debugging time later on. And I highly recommend that. Also, I've often seen that people write tests, and that's great, and we need tests, and I want to have high test coverage. Awesome, but what is missing? They only test the happy case, the happy pass. Oh, we need, what do we need? This API should return ABC. Okay, let's check if in a positive case it returns ABC. Well, what they didn't test? They didn't test for invalid input. They didn't test for, I don't know, weird edge cases. And because of that, the application could crash later on. It could end up in a weird state, because most applications have some kind of state, and they're not stateless. So when you are in a weird state, even following calls to that API might be wrong as well. And it is super important to check for both cases. You should always cover both cases, and not only check internal APIs, but please always use the public APIs to test all your passes, because otherwise you might have a feeling of having covered all your code without actually going through the real code path, and the actual real code path might have a different behavior. This is a code that I had to review as well before, and here, so validation functions should always be synchronous. That's good, because that's also the case here. Cool. So in the first try, there is a validate function, and if that throws, well, let's see what happens. Let's go into the catch clause down there. In the error case, well, we just extend the original error with only the message again, and so we now have the original message plus in the front could not do things. And then we call rollback from input. Wait, a rollback is normally an asynchronous operation on the database, but we never called the database. There's no entry. Why do we actually call the rollback if we only validated the input and never called the database before? That's wrong. Ooh. And now we rethrow the error. Seems weird. I don't know. Now let's go into the second clause. So the input was valid. Now we create the input, have the entry, and something went wrong. I don't know what, but the database says, wrong. And now we extend the error message again. We have the inner error with the original error message. Now they have a weird check if it's like an error of a specific class. And if it is from that class, they say they add an extra property on it and say it is that class. It is already that class. Why do you extend it even further? And now they throw that error because it is a wrap try catch, right? You have a top layer try, and then you have another try, and maybe another try, I don't know. And they throw it again, and so we end up in the outer error layer. And now we extended again the error message, and now it would write. Now it would say could not do things inner error foobar. Okay. I'm not really sure if extending the error in this case in all the time is really useful. I would say it obfuscates what is actually going on. Because the actual error thrown wherever it is should already contain the necessary information. Now we do the rollback. Okay, cool. But instead, what we could have done is just validate on the top of the code. If that throws, then wherever it is handled on the top layer, that should know what to do with invalid input. And then we don't have this weird rollback call for synchronous code. And we also don't have the weird nesting and so on. Don't check for any error instances. Actually, this code could look as simple as validate input, await db create input. That's it. That's how this code should look like. 2 lines. Rejections. So I said the old promises or the regular promises are actually not our savior. Well, async await came. Well, that's our savior because it makes the code readable. It makes it shorter. Now, it makes it readable. It makes it shorter. And now we are able to actually also use try catch as we are used to with synchronous code. Cool, cool, cool. Problem is there are a couple of side effects there. Or let's say difficult to know about cases. On the left side, we have 2 functions that reject, all right? Because they throw an error in an asynchronous function, every error in an asynchronous function will be returned as a rejection. And then in our actual application do things, we call foobar and we call the function bus. And okay, that's fine because we handle these errors right below, right? We have try, await A, await B, and we catch those errors. We don't. Because as soon as the first one is awaited and is rejected, the code flow from that point on will not go on. So await B will never be reached. And since B is also rejecting, we now have an unhandled rejection, and we will not log that. We have no clue about this error. This is pretty bad. And this is, of course, a stripped-down version where it's easier to spot this error. But just imagine it's a huge function, and it's significantly more difficult. Instead, just use something like promise all, await promise all AB. And then you would catch all these cases. On the right side, that's actually almost identical to a pull request for Node.js itself. And here we have a rejecting function. And we also have do things. And it looks all good, right? Because any asynchronous function, if you return something from it, it will be wrapped inside of a promise. And therefore, you don't have to worry that anything returned would be unhandled. Sadly, that's not the case. Because in this case, well, the return happens before the try-catch call. The try-catch is, so to speak, sync in, the return is sync in a way because you return immediately a rejecting function, right? And then the try-catch is called. So the error case is never going to be reached, and it is actually going to result in an unhandled rejection if you do not write return await foobar. You have to explicitly await the rejecting function at this point. And that's something a lot of people forget about because they just think about, oh yeah, it wraps everything in a promise, that's fine. Promise code is difficult to always write correct. And that's how something like that looks like. You get a unhandled promise rejection warning in Node.js. At least you know a little bit about it, but it's still not very helpful. And there are also often test cases that people write that are completely useless because they actually only tested partially the API. And here we have an API that returns 50% of the time, and 50% of the time it throws an error. And yeah, they want to check that it actually throws an error. That's the intention of this test case. I've seen code like that multiple times. and they just use try-catch in their tests, and then they validate the error. Well, even in Node.js, where a lot of people review code, one of these cases sneaked in, and we had an actual bug because we did not know that the API actually returned. We expected it to fail, but it did not always fail, and we did not properly test it. What you should do instead is just use similar assertion libraries, the Node Core one, Chai, I don't care, whatever, and use assert throws. That's normally the function that they have. That way you're always safe that the code that you're actually testing for indeed always throws an error. I've spoken a lot about the negative cases now, and this is not what this talk should all be about. Instead, I actually want to show you good patterns to write your errors in a way that you have a very clean code, very simple to understand, and so let's go to these patterns. First of all, error classes. Why classes? Because especially in JavaScript, I would normally always recommend composition over inheritance. For errors, it's a little bit different, because errors make your life super easy if you use inheritance on them. And when I start an application, I start with the top layer error class. That's my application error. And it extends from error, and it has the name of the current constructor that it is created from. And then I extend this application error class again. And I extend it with, like, let's say, a database error and a user-facing error. And there are probably more things that you want to extend from it. But let's go into more details about that. And you can extend the user-facing error again. So here, we say a user-facing error. When you have a backend API, you normally have a REST API. And as such, you want to validate your input. And when the input is invalid, you should return a bad request error. So if you just throw a bad request error, every developer in your company will know for what it stands. And you can already provide basic information in that error class. In this case, in just status code, which would be 400 for a bad request error, and you don't have to think about that anymore. Do not extend the error as like you explicitly add a property on it inside of your code. Just try to put everything important in the class already, if it's static information. And then you don't have to worry about, like, sometimes the developer might forget to add a property to that error, you know? And you have partial information to actually debug, and that's not good. We don't want that. That's not all. We can go further. We can extend the bad request error and have the constructor to accept more information, because sometimes you want to also know what user actually provided that bad input, and I don't know what. There's probably individual information specifically for your application. It's unique. And why do I use assert here? So while developing, I want to make sure all my errors actually do what I want. And an assertion call like this is just a simple if. It's super fast, doesn't slow down any code. And the error cases here should only be triggered, ever be triggered in tests and not in production code. So because we are humans, we make mistakes. It's fine. We just have to accept that we are not perfect. And when we are not perfect, we just try to make our life easier by validating our input. And this is just a very simple input validation. Let's wrap it all up with the error classes. I recommend to create an application-specific base error class. From that base error class, you extend multiple other classes that are specific to a specific layer of your application. A REST API, for example. Database is another one. And you want to validate the error input, at least basically, because when any developer would add a new instance of an error, they would normally also test that code. So you would immediately know if that error case would not work as expected. And you can now move that into a Node module that you can import in your application. And that's good, because now it's easy to access these error classes anywhere from your application. And you know that you want to have a specific version of this module. And when you import it, anywhere where it's used, it will be of an instance of that class. It's cool. So we can use it anywhere where we import it. That's what we want. It is the only source of truth. We don't have to worry about anything else anymore. Makes our code readable. Yeah, that's how I want to have my code. And we need abstract error modules because they just contain all the necessary information. I don't want to have it spread out in my application. Errors are often a second-class citizen in a way. They are often like, oh yeah, I had to also write an error, right? What do you have to validate again? No, this ends up in stuff like that. Cool, right? There's no error. At least that's what it says. Yeah, so I already briefly talked about these layers. What is a layer? Weird, but we have different layers because the express layer should be a user-facing error. Anything that has a REST API is a user-facing error. We want to tell them you provide a bad input, the entry didn't exist, you are not allowed to do this, and stuff like that. If a database error would happen, the user should not know about that error. So it's not a user-facing error, and the database should handle the errors differently from the REST API. And also outgoing requests are something where you have to deal with errors, because the receiving API might return an error to your application, and you have to know how to deal with them. So let's go into more detail there. This is the generic error handler for Express below, and on top is a route. So sadly, Express does not natively support async await, and that's why it's written a little bit weird, because you have to wrap it in a try-catch instead of just writing await database get data. But here, if that fails, it will be the error will be returned to the next function, and that ends up in the global error handler, which is defined by providing 4 arguments in the function. It's a little bit weird, but that's how it is. Now, the function itself is actually pretty simple now. So here you hopefully see why I want to have these error classes. Because now we are able to say, hey, is my error that I receive at this point an instance of a user-facing error? Yeah, it is. Cool. Now it's super simple because you already have the status code that you want to return to the user. It is automatically attached on the error class, so you don't have to worry about it. It will be always correct. And you might also have an error code that is specific for the information or the actual message for the user and the front end. Why use a code? Well, on the receiving side, it is easy to translate it into multiple languages. You return less data over the network instead of having a static message that you return. And it is also easy to change the error message no matter what if you just have a static code that is defined once and only once, and you don't have to touch that part of code anymore. Because it takes significantly more time to change code than actually just to change a language file, where you have a lot of entries defined, and it's possible to translate them. Anything that is not a user-facing error at this layer, well, that's an application layer, because we have no clue how it ended up there, and we should deal with that. So that's a 500, and we should return that to the user, no matter what. We should not return any further information, because that might be sensitive information, but we want to log that information to now be able to debug that code. Similar to the former example, just Fastify, which is like an alternative to Express. Here you also have a global handler, and here it actually supports native async await, and therefore we can just do it very simple. We say the database call, did it provide any entries? No, okay, dataset not found. Then we just throw an error. If someone reads this code, everyone knows it's a not found error, and it's, I don't know, it's super simple to understand. There's nothing else you have to write about it. There's no try catch, nothing. And if it works, then you just return the data, and cool. And we do the same thing in the global error handler as before. We check, is it an instance of the user-facing error? Yeah, okay. Then we return that to the user, and otherwise, if it's a different error, then we say it's 500, and sorry, can't do anything about it. Databases. So when you write the layer for the databases, it's a little bit different because it should be transparent to a user, and that's something super bad. If there is an error, like a network outage, you have a big problem. You want to probably immediately try to reconnect to a different database as a fallback and something like that. But maybe there was an ongoing call in between. Now you want to recover that because you saw you have this network outage in data center A, but you have a data center B that is independent, and you still want to provide relevant information to the user. So you just reroute that. You immediately connect to the different database, call the same query again from the error handler, in this case, and now return that information to the user. Hopefully this worked. And this error is obviously nothing that the user should know about. It's a little bit more complex, so I don't have concrete code here, because this is very specific of each application, and you should think about how your application works, what database you have, what fallback mechanisms you have, and what possibilities you can use. Outgoing requests. So this is a code that I wrote a while ago, where I had to deal with the Facebook API, and it was really tough, because Facebook had a horrible bug. They took ages to fix it, and well, let's go through it. So first of all, I validate the input. It's synchroted, right? So all good. If that throws, it would bubble up from the calling sites until my upper layer error handler would catch that error and know what to do about it. And now I call, the input is valid, so now I call my request, I call Facebook, and it returns an error. Well, first of all, I want to try again if there's a network error, because sometimes things happen and I just want to retry. And second, I want to circumvent the problem with Facebook, because Facebook often returned temporary send message failure, please try again later. That happened like 25% of some API calls, and it was random. It was like really bad. So we had to retry a lot of requests. And yeah, we just retry in this case, and after a little delay, increase the delay in between, and say, okay, hopefully now it works. I don't want to do that indefinitely, so I try up to 10 times. If that doesn't work, well, the user is already annoyed because it took way too long to actually receive any input. Now I give up and just say, okay, I have no clue how to actually access that data, and I will throw the error, but hopefully one of these 10 calls actually succeeded, and the user would still get their relevant information. And in between, I log everything I have about it to actually know what's happening, because without that information, I wouldn't even know that Facebook had these problems all the time. And there are a couple of debugging utils available, and then especially when you're using Node.js. So we have multiple resolves that I spoke about earlier. I said that the promise constructor is actually sometimes calling resolve or reject more than once. And we have promise hooks, we have proper logging, stack traces, unhandled rejection flag. Let's go into details there. Util Promissify. Instead of manually promissifying APIs, that is actually a correct way of doing it. Node.js provides a function to do that for you. And it looks like this for the same code. You just import Promissify, and you say, OK, I want to Promissify my get call. And you want to also have it for the correct this context. So you bind it to the database, and now you have the same function, but it's promissified. You can call it, and cool. That's good code, because it will always work. Multiple resolves. So multiple resolves is only an indication for an error, because it could also be triggered by different things. But here you will note about cases where a promise constructor resolved more than once. And resolve in this case also means rejected or resolved either way in either combination. And when you use that, this promise will never end up in a catch clause, because first of all, it's resolved with first call. The second resolve will just be swallowed just the same as a reject. Normally, you would not know about that. But you now have the possibility of hooking into the notification for the multiple resolves hook, and we get a nice warning. Here you know, OK, it resolved twice, the promise is first call, and the content was swallowed resolve. For the reject case, similar, it is the promise currently is the first call one, and then you get to actual content, which is the error swallowed reject. Cool. Now you also get the return value from console log at the end, first call. Perfect. And since Node.js 11, I implemented unhandled rejections flag, and I highly, highly recommend every one of you to use that flag. It was a very long and hard discussion to get to this point. It took around about 5 years. For me personally, to get that in 2 years. And the thing is, when you have unhandled rejections, it is by spec valid that your application continues to run. But if you do that, you end up in memory leaks, and you can have weird states. So the best thing to do for any rejection is to deal with it as if it would be an exception, not a rejection. And that's exactly what is possible with this flag. So you have 3 different modes. One is none, which just suppresses all output. You wouldn't get any unhandled rejection warning anymore, nothing. Then there's warn, which is the same as the current default, where you get a warning, but you would not get the deprecation warning anymore that your application will crash at some point, which is actually not true. We don't plan to do that anymore. We would just throw an error, which is exactly the strict mode here. You have the unhandled rejection is strict as flag in the call. And now we call the code that I showed you earlier that resulted in an unhandled rejection. But instead of having a warning here, we actually get an actual error thrown with that promised rejection. That's exactly what you want. And there's something new in Node 12, and it's freaking awesome. It makes your life so much better. So it's not only Node, it is also in Chrome in new versions. So also available in the browser. And here we have zero-cost async stack traces. What that means is, so far with an async stack trace, it would not point to the actual call site. But we spoke a lot with the VA team from Google to implement something that would still provide us with good information. And now they came up with these, because they are actually able to track each await call. So when you use async await, it does not only improve the readability of your code, it also improves your stack traces, which is the most valuable part. And the outcome here is normally you would just get some, I don't know, process, next tick, weird stuff, has no idea about the 1 and 2 function. Let's see how it looks like now. Oh my God. We have the call side of the 2 functions. It happened at 2 and async 1, async test, including the line number. This is really, really big. So yeah, please use async await as much as possible for that reason. You will make your life a lot easier when you use that. Let's summarize everything I said here. Specify some rules again to memorize. It's like the error classes are the first step to do because it's the basis to have a nice abstraction, easier to read code. Then you need the error handlers in each layer. So normally it's like, I don't know, around about 3, 4, that's probably 4 error handlers that you actually have. Do not do any in-place error handling, please. Do not wrap everything in multiple try-catch. It's completely obsolete normally and even makes your life more difficult. And it obfuscates what you normally need. Always use async await for the reason that I just told you about. Have expresses error messages because you want to know what the error is actually about. Use util promissify, return the error status and codes, and use more promise hooks. Thank you very much.
My microphone? Yes. Thank you very much. Really great session. And my summary number 1 is error you can make lots of errors in errors handling. And I think you can easily call yourself as CEO, Chief Errors Officer. And we have lots of questions from audience, so let's just see it and let me ask you some of them. So first, you mentioned common class for the whole application, which could be imported in any place of the app. Are we saying about some form of singleton for the whole app, or how do you see this? I believe it's about this abstract error model you mentioned.
So when you create these abstract error classes, you want to have them all in one place. And you want to be able to use them anywhere in your application. And it is easier for you to just create a module, in this case, that where you put all these errors in there, and then you import that in whatever your actual application looks like, and you can use these and create these error classes. And when you now test for the instances that are created in that module, you will also have the correct instance. If it is coming from a different module with a different error module, then it would not be caught, which is actually the intention, because the current module that you're working on is the one that you want to deal with these errors. I hope that clears it up.
Yep, fair enough. The next one is how to handle errors if you don't have you don't know their types in advance. For example, I don't know, 10, 20 different types, and it can result with super long switch or multiple if with instant off statements. What is your approach on this?
So normally, that's what I just meant. Normally, there is no reason for these big switch cases anymore when you use the abstract error classes, because you already provide a lot of information inside of the error classes, and then you can just access that information and know what it is about. When you do the validation steps, well, you have to do the validation steps one way or the other. So let's say you do, okay, first of all, I want to know, is the input valid? If it's not, then I'm going to throw a bad request error. Am I actually allowed to access that data? No? Well, then I throw a prohibited error. is the data actually available after calling the database? No, okay, now I throw a not found error. So you always explicitly throw the error in these cases, and there is no need for big constructs where you still, I don't know, check for other things. It should be pretty straightforward in the error handler to distinctively only check for the for instance of the current class that you care about in this error layer.
Okay, cool. The next question is, what is the best way to refactor throws in promises to cancel them?
To cancel them?
Yes, if that's ever possible.
There is no way of canceling a promise. As soon as you...
not promises, but throws in promises.
A throw in a promise?
Yeah, when you throw error in promise and you want to cancel, if I understood the question correctly.
But if you are in an async function and you throw, it would result in a rejection, which you cannot change anymore at this point. Like as soon as you throw something, it will always bubble up. It will always end up in the next thing that tries to handle it. Or if it doesn't handle it, well, your application is going to crash.
Got it. Very, very good question, and actually I had the same one. Do you know some resources with guidelines, best practices, where we can get all the information similar to your session in easy-to-use way?
Yeah, I got that question before as well, and sadly, I don't have any further places besides in my head, so to speak. And yeah, I'll write a blog post about it at some point, but...
Do you blog yourself?
Rarely.
So let's ask Ruben to write some cool article, okay? Let's do it by just applause. Yes, so now you don't have a chance to keep silence. You are a member of TC39, right, or contributor?
I'm one of the most active collaborators in Node.js.
Awesome. And anything happening there related to errors handling? Something new so we can expect to simplify our life?
Well, the flag is super new. It just landed, I think, like, I don't know, 2 months ago or so. Mm-hmm. And I'm going to backport that to Node.js 10 as well. So it will hopefully be there available soon as well, because you probably still use Node 10 as it is an LTS release. Please don't use 8. Try to use 10 already, because 8 is also going to be outdated soon and not maintained anymore. And we are going to probably improve the multiple resolves hook as well, because at the moment, when you use promise all or promise raise, that actually has the same underlying functionality. So it is just sugar pretty much on top of a promise constructor internally. And that's why if you have multiple rejections in there, it could also end up in that hook. And that's why it's only a warning and not recommended to actually shut down your application, because that would be bad. You always have to look, is this actually a valid case? And do I have things like that in my application or not? And we want to remove those cases from the hook, or either or as an alternative, provide information what type it is of error. So if it would come from promise all or promise raise or a general promise constructor.
Cool. And related question: any modules or packages you could recommend to simplify errors handling? And not to introduce new errors, but to simplify our life. Just not to maybe write this amount of boilerplate, or how do you see this? Are they available at all, or they are too custom or it's not possible because they have to be very custom for every custom app?
So there is one nice application that has input validation, for example, that is super good. That is Joy. But the problem with Joy is you don't have your own error classes, and that's why I am not always using it. But the abstraction that they provide to validate input is super good. So you could have a look at that.
Cool. Any special advice for Redux or RxJS stuff?
Second, please.
Any special advices for Redux or RxJS?
No, sadly not.
So it's just general
Yeah.
advices. Yes, the last question is about the download link for the slides. I believe organizers will do this job. And yeah, last question from me then. How do you feel current state of JavaScript as a language? Is this good enough to handle errors, or it might be better?
So JavaScript itself in its current state is actually pretty good. We advanced a lot. We have a lot of new language features which make our lives easier. There is something more that I would love to have about error handling, but it's not easy to implement in JavaScript, and it would be a little bit difficult to describe everything now. There is one more thing that I want to have in Node.js as well. For example, sometimes people struggle with promises that do not resolve when the application closes. That means that they never resolve that promise because it doesn't keep the event loop alive. And that's an error. And I'm actually planning on implementing something to detect that and then to also tell the user, hey, you have while your application shut down, there was still an ongoing promise, so you didn't handle it. And you should make sure that this promise is actually resolving at some point.
Cool. Thank you very much.